with that, our first speaker is Jan Mußmann. He is CTA at UP-on-You, and he will talk about deploying a multi-vendor EVPN fabric based on automation tools like Ansible and Netbox. Enjoy.
Thank you very much. Okay, cool. Yeah, a little bit about me. I'm Jan. I'm CTO at UP-on-You, and there I'm responsible for the data center and core networks. We are a regional IaaS and SaaS provider with our own data center, so that is why we need all that stuff. I'm interested at work, mostly in data center networks, provider networks with SRv6, and all this with testing and automation in the background. And also we do a little bit security stuff like forensic analysis for locals, etc. In my free time, I like doing computer graphics, digital imaging, and some optimization problems, convex optimization programs. So this is also fun, but yeah, not the topic here. You can see all my projects on my GitHub, and also feel free to contact me on Mastodon or Matrix if you would like to chat about all the topics. So a little bit what I'm doing today. So I show you why we are doing this automation, and then I'll show a little bit how we build it, what are the building blocks and tooling we use, what is our final design and deployment strategy, and what were some challenges in there, and then I have a short conclusion, what went good and what not. At a starting point, we have a legacy data center, very, very classic, with a large layer 2 domain, so many switches, with lots of different vendors. We have all had to configure it all manually. It was a lot of pain to have a constant documentation in all the tools. We have some Excel files, some MediaWiki. Also, we use Netbox in the background, but there was no plan to keep everything consistently. And we had no automation, so each colleague has to log into the switches, configure the VLANs, etc. Challenges are, it takes a lot of time. We have to do manual documentation steps, and it's very, very redundant and error-prone documentation. So we had some hard problems that the documentation was not right, and we had to get rid of it. So we had some requirements for our new data center and our new deployments. This is finally a leaf-spine architecture with VXLANs and EVPN. We do not want to do any manual configuration on any device anymore, and we would like to have the same configuration process for each device over all vendors. So we do not want to learn Cisco, we do not want to learn Juniper or Arista CLIs. We would like to have one consistent configuration and don't care anymore about vendor-specific implementations. We would like to have a single source of truth, only one documentation, also some others more readable, but only one source, with then automated text documentation. And we need easy tracking of changes and debuggability, and also because we would like to use multiple vendors in our network, we set up everything on open standard to be vendor independent. And this is our proposed process for this. We have logical configuration which lives in our Netbox instance. This is completely vendor independent, and then we do an inventory generation, which generates us some Ansible inventories with group vars, host vars, etc. Then we run through the Ansible templating engine, which generates us overall documentation of the fabric, and also then generates network operating systems dependent configurations, and then we are again vendor dependent, of course. After that, we use Ansible playbooks to push all these configurations to our fabric and to actual switches. In this step, we can also do the configuration backups. Next step, which we are currently working on, is also to do a complete validation of the fabric, check if each cable is connected correctly and the endpoints are correct, access routes are correct, etc., and then generate also reports on this. This is not completely implemented yet, since we are still working on, but with this pipeline, we would be able to do this. Yeah, a little bit short intro to Netbox. Netbox is a data center inventory and IP address management tool. It has a very powerful APIs and comes with different SDKs. The main and mostly supported SDKs for Python SDK. It has custom fields and variables to extend it. You can use custom scripts to have some automation in the background. And one advantage for us is we already used it. We are familiar with that. And now we are making it our main tool. It's our source of truth for all devices, all cabling, every VLAN is in there, every VRF is in there. We have each VNI which is associated to a VLAN or VRF is in there. The autonomous system numbers are in there for the switches and also all the prefixes and also the management IP addresses. And this is how it looks like here for us. We have, this is an example of our device table with some devices in there. These are all, there's spine switches, leaf switches, etc. And now we can generate with devices also nice rack layouts to keep everything cable, look into this overview and find our devices in the rack. This is very nice. We have all the device interfaces. This is an example from a leaf switch. And also we now knew which port is connected to which compute node and which interface on the compute node. This is a VLAN configuration for a switch port. And you can set up in Netbox that, like on a switch, you can say this VLAN is tagged on this port, this VLAN is untagged. And basically you can configure the complete switch and the complete ports completely in Netbox. And if we put everything together, we can do nice things like cable tracing. So we define a starting point. For example, you would like to, the switching port, but not where it's connected or to which NIC it's connected in the server. You can click the port and then trace the cable completely to the server, also over other patch panels in between, etc. And now in the data center, I don't know how good you can see it, but we have every cable has a label, and we can find it in Netbox, just putting in the ID and then have a configuration there. One problem in Netbox is how to populate it, because the user interface is very good for small changes, but if you make lots of changes, it's a little bit slow. You have to do it multiple times on different parts in Netbox. So it's not a great tool for initial planning, and very challenging if you have to create lots of devices. Like in our case, we would like to deploy a complete new data center in it. Bulk imports are great, but very hard to deal with if you have very much cross-references like VLAN IDs, VRFs, etc. So what I recommend to do is, and what we did in the end, is to use some custom short snippets with the API, with PyNetbox, with custom CSV files, where we can put in VLAN names, VNI identifiers, etc. in one big file, populate the file, and then do an initial little import. But then, of course, throw away this file because we would like to have our Netbox, the main inventory tool. Yeah, Ansible is an automation tool with many collections available, so plugins from different vendors for different vendors. It's completely Python-based, based on Jinja 2 templating engine to generate config files, documentations, and other configurations. And it's a great tool. It's highly customizable and extendable. And one tool we found then, which fits very good our proposed process, is from Arista, the Arista Validated Design Ansible collection, which is able to generate a complete network fabric based on a logical configuration. You don't have to put there each interface configuration. You have a very high config. I will show it right now, and it outputs a complete switch config. So you go into a design module, design your fabric, have then a so-called structured config, which is a nice way of showing a switch config, but it's completely in YAML. Then you have another module which generates the final configuration, and then a deployment part which pushes this configuration onto the fabric, onto the switches. This is how the structure looks like. So we have variables for the whole fabric. You can define there your users, the BGP group, peer groups, with passwords. These are example passwords, not real ones. The MTU for the uplinks, etc. So this is basically variables for the role fabric. When you generate your interface configuration or your spine switches with the uplinks, your nodes. This is one of the leaf configurations where you can configure your uplink interfaces, which go to the spine switches. And yeah, you can see it's it's not like a switch config. It's more of a logical configuration how the data center really looks like from an overview. And this is all a layer 2 leaf, so it would be which you can use for IPMI, etc. On this, we define network services for tenants. This is an example tenant which has one VRF, virtual network identifier, some switch virtual interfaces, some VLANs, and you can define multiple tenants in there, and then it's converted. For the endpoint side, you define which server you have, which endpoints to the server set, on which switch ports they terminate, and which switches are in there, which VLANs would like to configure on the interfaces, what is the native VLAN, is it the trunk port and access port, etc. Yeah, so basically AVD meets most of our requirements from the proposed process, but yeah, the problem is it's very, very Arista specific. So the all configuration generating part does not fit our requirement that we have to be vendor independent. But it's very cool. The tool is completely open source and Apache 2 licensed. So what were basically what were our to-dos? We have to add additional vendors to the AVD and transform the Netbox data into this kind of inventory that I showed before. For additional vendors adding to the AVD, we have the input variables in the design process are already mostly vendor independent. And transform this logical configuration into the abstract switch configuration. We added support, or we created a fork from AVD and added support for Dell OS 10. This is our second vendor. We had to then consider some specific parameters like the OS 10 multi-chassis link aggregation variant, VLTI. There are some specific things for EVPN configuration. We had to merge VLANs with VLAN interfaces because OS 10 does not know directly VLANs, only uses VLAN interfaces. Some other platform-specific parameters like management interfaces, etc. But it's very important in this step to keep the design part of a module as vendor independent as possible. There are some things which is not possible to keep vendor independent, but overall it's possible. One, we have to abstract the configuration generation part. It uses these YAML abstract config and generates these vendor-specific configuration files. We then have Jinja2 templates, which define the blocks in the configuration files of each vendor. And this is what we have to create for each vendor to render this abstract configuration into an actual switch config. And after that, if we have a final switch config, we use the available Ansible connections and modules to deploy it. So for most network operation systems, there is an Ansible module, often called OS_name_config, to backup configs, but also to push configs on a device. So for EOS and OS 10, these are the modules, but there's also one for Cisco and for other things. After that, we have to transform the Netbox data into a usable inventory. To do this, we added a custom fields for the missing parameters, which Netbox just doesn't deliver out of a box. And after that, we created a custom CLI tool, which is able to build these Ansible configurations. It generates the complete inventory files, the group vars, the host vars with the connection settings, and also we added support for trunk cablings, which is a little bit strange implemented in Netbox. So these are the custom fields we defined. We defined the BGP number, the endpoint type, some supporting variables like IDs. But we had tried it to keep it really, really basic and do not add everything, but only these things we need to deploy our fabric. And all these fields we can set up in the CLI. So this is an example we have from a switch. A switch has only these additional parameters, the BGP RS number, the node type, if it's a leaf, a spine, or a layer 2 leaf, the network OS family, where we know in the end on which devices we are deploying, a switch group name, a switch ID, and the platform, because also if you have the same OS, the platform can differ. Maybe the management interface number is another one, or the switch doesn't support even MLAG or something like that, so there are some platform-specific settings in the background. We also have to support overrides, because some parameters cannot be set in Netbox, or it's not sensible to set them in Netbox. It's possible to set override variables to specifically say, okay, this is maybe wrong in Netbox, or maybe if there is no way to set this variable correctly. There's a directory structure which gets merged with the Ansible inventory, and directories are merged, lists and other variables will be overwritten because there was no other way to do it right now. And the override files have the same directory as your Ansible inventory. And this is how a complete playbook looks right now for us. We have our playbook root directory. We have an Ansible configuration to automatically find where the inventory lives and which collections we use. We have a build playbook, which builds our configs, and then a deployment playbook, which pushes the configurations onto the devices. In the inventory, we have a backup directory where we pull all the backups in, a documentation directory where we generate the automated markdown documentations, group variables, host variables, and the intended directory. In the intended directory are the built configurations which we would like to deploy, and the inventory files. And now, when we have the inventory tool with a config file and some overrides for the data center and the network services. So this is how our deployment framework looks like. We make some change in Netbox, like adding a VLAN. Then we create a backup of the current configs with a backup.yaml playbook. Then we run our inventory generation tool. We can generate everything, or we just generate some subsets, like only group variables, only host variables. When we rebuild the configuration, and check if everything looks good. If so, the Ansible playbook, or we use the playbook deploy to deploy it on the switches. We have a problem with Dell OS 10 because there is no replace command, so we can only push to OS 10 new or additive configurations, but don't remove some configurations. So it's not possible with OS 10 right now, but we're working on it to make this also supported. Now, this is our final design of our data centers. Our vendors are Arista and Dell. We have a complete design like the BGP in the data center RFC. We use one autonomous system for the spine switches and one for each leaf pair. We're using BGP unnumbered, or BGP with IPv6 next hop. And for the overlay, we use two loop interfaces, one for the EVPN peerings, or the EVPN BGP peering, and one as the actual VTAP interface. So for these multi-vendor fabrics, we have some challenges. For us, BFD is not supported for all vendors, or for next hop. This doesn't work on their switches. We have different reserved VLAN ranges, which can differ for some devices. We have vendor-specific protocols like MLAG, VLTI, etc., and some incompatible defaults, or some not everyone agrees on the same standards what to use as default configurations for EVPN or BGP. This is an example where we had to dig very deep what to do, and it's not so well documented for OS 10. So the situation was we have everything set up, the Arista devices were great, the routes between the Dell devices were great, but between, it was not possible to get reachability. And the logs look good, everything looks really normal and fine, but it didn't work. So when we take a look into the captures, this is the BGP message. We see there that they have an invalid next hop attribute. Okay, then now let's look into the actual update message, and now we can see that the switch sets the doesn't set the next hop IPv6 address. This is strange. This is okay in the standard on the VLC, but the Arista devices cannot work with it, and the Dell devices cannot work with it by default if there is something in there. So what we did is lots of Googling, and now finally out, okay, there is one specific command you have to set for that. The Dell switch sends the next hop information or a link local next hop information also in the IPv6 address field in the update matches, and then also accepts link local addresses from a peer with IPv6 local addresses. As a conclusion, we have a very, very powerful reusable pattern with this generating from Netbox, generating Ansible inventory there, and then doing changes on configs, etc. We're using also this already in other deployments, like in our core network with iOS XR and SR. This is a SRv6 deployment. We use Netbox everywhere now in the company, a single point of or single source of truth. There's no manual management more. The vendor interoperability, comes not out of the box. You have to sometimes have strange problems and dig into what's happening. Some vendor deployment problems, like there's no config replacement mechanism for their switches. And even if you keep it simple based on open standards, you will run into some problems. But I think as open you will keep it, as less problems you will have with vendor interoperability. Some remarks: it's very important if you do something like this to back up your Netbox and your repositories, because you don't have config files anymore. You have a big database with lots of dependencies. Very important also to have a restore strategy for this. Back up your database, media files, and scripts. We have a pipeline which store it in a Nextcloud, encrypted, and then have some emergency notebooks to deploy our Netbox with Docker Compose again. Also, we still back up switch configs and creating diffs to check if everything is working correctly. And also, what I would recommend is to always, if you plan something like this, test vendor interoperability beforehand and not in the middle of a project. Some future plans. We would like to do some more automation and validation. For now, we execute Ansible manually. We would like to put it into a CI/CD pipeline. We would like to generate more complete topology graphs. Have to add more Netbox comfort function, like adding a VLAN. You have to click through a lot of steps to just implement one simple thing, which is something we would like to optimize. We would like to add a feature to also do a config replace style thing in Dell OS 10. And also, we would like to make the complete tooling available as open source. It's already on GitHub. An example is missing right now, but basically you can download it and test it yourself with Netbox. And that's it. Thank you very much.
Thank you, Jan. Okay, do we have questions? 1, 2, 3. Okay, let's start. Please remember to state your name and affiliation.
Hello, Jörg Jungermann here, Northern Data. Nice to see other people also working with automated systems and Ansible. Are you using Ansible inventory modules, or are you using inventory executable scripts that just output JSON? And how much is your deployment? How large, many machines you are using? Because we have a lot of machines, and inventory generation takes a lot of time, and this is also not so awesome.
Yes, it's a small deployment right now, and it's already taking a long time, but we do not use plugins for Ansible. The Netbox inventory tool generates YAML configuration files, and it's completely independent from Ansible, so you can use it also with other tools if you like. It's just a Netbox orchestration tool, and we're using it, I think, with 15 devices right now, but it's, yeah, I know, but it's not, the generation is not the slowest thing. Netbox is sometimes really slow because you have to query a lot of things, and the API is not the fastest. We don't care so much about this because we generate everything beforehand and then do the deployment. But yeah, I tried to optimize the process to query Netbox, but I think we can do better.
Okay, thank you. 1, 2, 3, and I think then we're closing the queue.
Molly Miller, Flying Circus Internet Operations. We've also deployed an EVPN fabric, and one problem we've had has been debugging when things don't work. So I'm interested in what tools you've been using for debugging both the VXLAN side of things and the EVPN control plane.
Yeah, so one thing is we try to have every vendor is able to ship a testing appliance for Container Lab. So there are some things you cannot test in Container Lab, but most things you can. And then we have using Linux tooling, etc., to check some errors. In the field, we are using switch mirroring, SFlow, and NTOP-NG.
Hi, Michael from NSCon Network Consulting. My question is, I've seen you using individual fields in Netbox. Can you explain why didn't you use configuration contexts?
Yeah, we would like to have it nicely shown in the user interface so that also new people getting in our team can see it directly in the interface and not have to look into a JSON config or YAML config in this configuration context.
Okay, thank you.
Sebastian Wiesinger, Norris Network. You are doing multi-vendor, and the question I have is why? Because in my experience, you invite a lot of work if there's not a reason for it.
Yes, there. Yes, it's a little bit historically because we had some servers we had to support with 10 gig, and I had already switches for this, and we would then had to buy new switches only for 2 years or 3 years, and so it's why we deploy also Dell OS 10 with Arista side by side. And it's always nice to know, to have the option to have always a different vendor in there, because there are bugs and yeah.
One question from the internet. Do you rerun the Netbox inventory process again for verification, or is it just used once to initially feed the Ansible config process?
Currently it's run once or every time you do a change, but it's planned to also do it for verification to check if every cabling is correct, etc. So we will do it, but we don't do it yet.
Thank you.
Thanks.
Da oben geht's.